So, you want to live on the moon. Theoretically, it is an incredibly fascinating concept, an expensive and technologically advanced city of the future protected by gleaming glass domes. However, in reality, living on the moon will pose numerous challenges for a significant period of time. The vision of metal buildings and glass domes, those that we see in science fiction movies, is unlikely to become a reality for the moon settlement within this decade for sure. But would we ever be able to call the moon a true home away from home? Personally, I'm envisioning any activity happening on our satellite as a place where individuals embark on a long-term work assignments. But it is not a place where people truly settle. Take people in Antarctica, for instance. Same concept will apply to any moon expedition. If your intention is to seriously consider the idea of building a city on the moon, the most viable options to begin with today would likely involve either underground living, utilizing 3D printing technology to create rock-based structures, or residing within pressurized habitats akin to balloons. Prior to the actual human return to the moon scheduled for late 2025 with Artemis 3 mission, let's envision how a long-term life inside a lunar colony can be sustained on the practical side of things. Subscribe to the channel and let's talk about how we can make our moon at least a little bit more hospitable for human life. You're watching Adventures in Space. About a year ago, everyone's attention was captivated by Elon Musk's vision of establishing a self-sustaining city on Mars. Clearly, his statement of transporting 1 million tons of cargo from Earth to Mars, needed for the colony, may seem daunting, but Musk promises to build 1,000 Starship rockets that could make it achievable. Each rocket would only need to deliver its cargo capacity of 100 tons 10 times, and voila, we successfully colonized Mars. However, numerous obstacles stand in the way, such as the infrequent Mars transfer window that opens only once every 2 years, the lengthy 6 to 9 month travel time, and the multi-year round trip for each Starship. Realistically speaking, this ambitious project would take several decades to accomplish, even with potential advancements in space technology. Nevertheless, while Mars appears to be the primary focus, what about the moon? Although Musk shows limited interest in the moon, it possesses considerable potential. If 1 million tons of cargo are needed to build a Mars city, could the same amount suffice for a lunar settlement? At first glance, it might be tempting to assume that less cargo would be required for the moon, given its smaller size. However, it is unlikely that the quantity of cargo needed would differ significantly. Therefore, sticking to the 1 million tons estimate seems plausible. The advantage of the moon lies in its proximity to Earth, with travel times to the moon ranging from 4 to 5 days, covering a distance of merely 240,000 miles. A fleet of 1,000 ships could transport the required cargo in a couple of months. Admittedly, deploying 1,000 ships might be excessive, as it would be challenging to pack and coordinate them efficiently. Alternatively, employing 10 ships for 1,000 landings would be more practical. It is important to note that Elon Musk's pursuit of Mars is not misguided. For every advantage the moon offers, there are corresponding significant drawbacks. One notable obstacle is the extreme temperature variation on the lunar surface. During the night, temperatures plummet to a bone-chilling negative 280 degrees Fahrenheit. Conversely, during the day, temperatures soar to a scorching positive 260 degrees Fahrenheit. So it is imperative to devise effective methods of insulation for a moon city. To create a habitable lunar environment, a practical solution would involve constructing a low and dense settlement and subsequently covering it with lunar regolith, the dust and small rocks that blanket the moon's surface. A thick layer of regolith serves as an effective insulator and could potentially be mixed with a binding agent to form a dense, concrete-like material. Besides thermal insulation, this barrier would also provide protection against meteorites and solar activity. On Earth, our atmosphere shields us from these dangers, but the moon lacks such protection. Although the Moon possesses a minimal exosphere with approximately 100 molecules per cubic centimeter, it pales in comparison to Earth's exosphere, which boasts 1 billion molecules per cubic centimeter. The critical differentiating factor here lies in the absence of a magnetic field on the Moon. Earth's powerful magnetic core repels solar wind, whereas the Moon lacks this critical defense mechanism. Even if the lunar atmosphere were denser, it would be susceptible to rapid dissipation under the onslaught of solar wind. Mars, while also facing this challenge, is relatively better off, as its atmosphere, although thin, is more substantial than the Moon's. Furthermore, Mars possesses a sizable gravitational force, which provides a glimmer of hope for densifying its atmosphere at a rate faster than the Sun can blow it away. The Moon, on the other hand, struggles to envision a scenario where such atmospheric density enhancement could be achieved. Additionally, the Moon's weaker gravity, which is only about 15% of Earth's gravity, raises concerns about its ability to sustain human bodies. One notable advantage of the Moon, when compared to Mars, is the ability to establish a more flexible and temporary presence. A trip to Mars would necessitate a minimum 2-year stay on the surface, coupled with a round-trip transit time. The effects of such extended duration on the human body remains uncertain, and once committed, there is no easy way to abort the mission. In contrast, while an indefinite stay on the Moon may not be feasible, there is currently no reason to doubt that humans could inhabit the lunar surface for a year at a time without harm. Perhaps a rational system could be implemented, with individuals spending 1 year on the Moon, followed by 1 year back on Earth. The relatively short travel time of a few days allows for considerable flexibility in terms of shifts and rotations, thereby facilitating a more manageable lunar presence. Considering the vast expanse of the Moon, which spans approximately 15 million square miles, accommodating a city with millions of people seems entirely feasible. To achieve this, several fundamental requirements must be met, starting with the essentials of air, water, food, and power. Surprisingly, the Moon presents potential solutions for each of these needs. Oxygen, a vital component for human survival, can be extracted from the lunar regolith. On average, each cubic meter of regolith contains 1.4 tons of minerals, including approximately 630 kilograms of oxygen. Given that humans require around 800 grams of oxygen per day, 630 kilograms would sustain a single individual for approximately 2 years. Electrolysis, a process of extracting oxygen from lunar resources, could be employed to meet this demand. Additionally, water resources are believed to exist on the Moon, both in the form of ice at the bottom of craters and extractable from the regolith through baking and condensation. To ensure long-term sustenance and a well-rounded diet, the cultivation of plants become essential. NASA has already conducted experiments on growing plants aboard the International Space Station, successfully cultivating leafy vegetables. This breakthrough provides a solid foundation for future lunar plant cultivation, as leafy vegetables alone can fulfill crucial nutritional requirements. Moreover, the importance of communication cannot be understated. Establishing reliable communication systems is crucial for transmitting vital information and maintaining psychological well-being among lunar inhabitants. Technologies that facilitate video calls, live streams, and other means of connection will be essential for lunar residents to feel connected to the broader human community. In this regard, SpaceX's Starlink project shows promise. By leveraging laser-based communication systems in their Starlink satellites, SpaceX aims to establish high-bandwidth, low-latency communication between Earth and outer space. Regarding power generation, solar energy will likely serve as the initial energy source. However, as a long-term solution, the utilization of helium-3 presents an intriguing possibility. Helium-3 is an element found on the Moon's regolith created through the absorption of solar radiation. While Earth is fortunate to be shielded from significant solar radiation, the Moon's surface offers an abundance of helium-3. Researchers believe that as little as 100 kilograms of helium-3 could power a small city for 1 year. Exploring the potential of harnessing this element for power generation would provide an efficient and sustainable energy source for a lunar settlement. So, considering all pros and cons, do you think that a lunar city, or at least a simple moon base, may occur in the near future? Drop all your thoughts and comments down below, and don't forget to subscribe to the channel. We do 4 essays every week in relevant topics, and if you like this video, click this next video on your screen to watch how NASA actually plans to build their moon base during Artemis program missions. As always, this was Georgie with Adventures in Space, and I will see you at the next one.